Okay, so we're just going to finish up this example here. We're on part C now. I'm going to keep my other page nice and close because I'm still using information from the other page. So part C says, find the population distribution 3 months into the future from the initial population. So again, here we only use the number of cycles in a population. Well, here they didn't give me cycles, they gave me a number of months. Well, we know that our cycle is, what did we say it was, 3 months long. Well, to find the number of cycles, you just take the number of months they gave you and you divide it by the length of the cycle, which is 3 months, which tells me that 24 divided by 3 is, we need to find the 8th cycle. So I can just go ahead and use that equation that I did before, my p sub 0 times L, and I'm going to raise it to the 8th power this time. And I can just go ahead and use my calculator for that. I know my population vector is in A, wrote myself a little note, and my Leslie matrix is in B. And I'm going to raise it to the 8th power, so you just hit the little caret button and to the 8th power and hit enter. And it's going to give us our new matrix here. So we can see that as we go, our decimals are going to get kind of crazy here. We're at 1, 2, 3, 4, 5, 6, 7, 8 decimal places, and again, we're just going to pick 2. The further out you go, the more accurate it stays, but we don't have that much room to write it all out, so I'm just going to stick to 2. So 21.0, I'm going to round the 2 up to a 3. I'm going to go ahead and keep going here. Oops, that should be a 2. 8, 10.90, 9.46, 7 point, that rounds to a 0, 1, 4.27, 3, 4, 5, 6, and that's the end of it. Yep. Alright, so there is that. Okay, so here you're going to go ahead and I want you to do the rest of this on your own, and I'm going to have an answer sheet up in the front of the classroom. You can check your answers. But they want you to calculate the population after 25 cycles, population after 26, the population after 27 cycles. So all you're going to do is you're going to use that equation and you're just going to raise it to whatever the subscript of the p is. That's the exponent you're going to use, and for each one you're going to get a new population vector. And let me just kind of give a little refresher here, because in part E they want you to find the percent change. So for those of us who don't remember about percent change, let me just give you the equation. So to find percent change, I'm just going to say percent change is equal to, we're going to say the old minus the new divided by the old amount times 100. And that's going to give us our percent change, and it's just going to be some sort of number. If it is a negative, so negative, it's going to be a percent decrease, because we never represent percent as negative. And if it's a positive, it's going to be a percent increase. So for the first one, if you're going in between P25 and P26, you would do, let me do that over here, so you would do P25, the total of that population, so you're going to take that row vector, add them all up, and that's the number you're going to be using because they want the total population. Subtract the newer one, so you're going from P25 to P26, so you're going to subtract P26, whatever the total of that row vector is, and you're going to divide by the old one, which is P25, so whatever this number is, it's just going to be the same on the bottom, multiply it by 100, and that's going to be your percent change. You might have done this in science class before, one of your chemistry or physical science classes, one of them, but just a little refresher. So again, go ahead and complete this, and there's another example for you to go through, and check your answers with the sheet up front, and ask me if you have any questions.